So in this video I'm going to go through a harder example question using the sine rule and your knowledge of the sine graph. So we've asked to find this angle here theta, and in order to find theta we first have to find this angle here b. So we can do this using our sine rule. So sine of b divided by its opposite length, which is 700, equals sine of this angle here, which is 15, divided by its opposite length, which we worked out earlier as 253. And to find sine of b, you just have to times this 700 by both sides to get 700 sine of 15 divided by 253. Then we know to get the angle on its own you have to do the inverse sine function of this fraction. So sine minus 1 of 700 sine 15 divided by 253 gives us our angle b. And we get a value of b as 45.73345. Sorry. But if we look at our triangle, we can clearly see that b is an obtuse angle, meaning it's greater than 80 degrees. And what happens here is that if we draw the sine graph, so we got sine b as 700 sine 15 over 253, and that's equal to 0.7161. So if we draw that line on the graph, 1 is there, so 0.7161 will be about here. And if we draw down to the x-axis from there, we can see that it gives us two values of b. So the angle we obtained was 45.73, and that will be this one here. Well, in fact, we're looking for this one here because it's an obtuse angle. So to find this, we can see that the distance from the x-axis is the same on either side of this curve. So all we have to do is 180 take away our 45.73. And that gives us an angle of 134.26657 degrees. And that is the actual angle of B. So that's something to look out for. Always look at your triangle before just putting an answer down, because it could be that you have to look at the sine graph to work out what the actual angle is. So now we know that b is 134.26657. To find out theta, we know that a straight line equals 180 degrees here. So we just do 180, take away our angle b, and that should equal theta. So that's when you get an angle of 45.73 degrees.